In this video, we are going to continue talking about the constant of proportionality and kind of how to use it. So, reminder, relationships are proportional if they can be represented by the equation. So the equation that links the two things is that y equals kx. So remember, when they're next to each other, that means multiplying. And k is that constant of proportionality. Let's make a note that it's the unit rate. Okay, right? These two things are linked. We're kind of moving away from using the word unit rate, but it's the same thing. So we're going to use that information to kind of write about these. All right, so it says that there are two coffee shops in town that charge different prices. Those prices are proportional, but some of the missing information is missing from their lists. So we're going to fill in the table. The first thing I'm going to do is find the unit rate. How much does it cost for 1 cup of coffee? So to do that, my cups of coffee is the x value, and the cost is the y value. So I'm going to take the constant of proportionality comes from y divided by x. So I'm going to take my y value, 825, divided by the x value that goes with it is 275. And I'm going to double check this one to make sure that it is proportional. You cannot see that calculator, can you? Let's see if I can't fix that. That's a little better. Oh, there we go. So I'm going to take the x value, 13.75, divided by the y value that goes with it. It is 275. It's always good to check. So at Seattle Coffee Works, it is $2.75 per cup of coffee. So 1 cup of coffee is going to be $2.75. If I know that they're $2.75 each, I can take the number of cups of coffee, 2, times that unit rate. I'm just going to note that I'm doing times to find the cost. So it's going to be $5.50. I can apply that same thing. I can do 4 times the unit rate to find the cost for 4 cups of coffee is $11. And then 6 times that unit rate, $2.75, it's going to be $16.50. So we're going to apply that over here. I'm going to find the unit rate. If it's $5.60 for 2 cups of coffee, to divide, I'm going to take the y value, 560, divided by the x value that goes with it. So each cup of coffee is $2.80. I'm going to double check this one. Oops. Divided by 6 is $2.80. Your calculator just does 2.8. Since it's money, you can add a 0 at the end to make it look like money. So $2.80 per cup of coffee. I'm going to multiply the number of cups of coffee to find the cost. So 3 cups of coffee times $2.80 each is going to be $8.40. 4 cups times $2.80 each is $11.20. 5 cups times $2.80 each is $14 even. And that one's already filled out for us. So take a second, write about what you notice or what is different about the two tables. So the main thing I'm seeing that is different is each shop has a different cost per cup. Right? 2 different stores, 2 different prices. That's reasonable. But how do we know that each one is proportional? How do we know that at Seattle, it's proportional, the cups of coffee to the cost? How do we know that for Houndstooth coffee, it's proportional? Well, what does it mean proportional? Each shop has a constant unit rate, right? When I do y divided by x, I'm going to charge the same price for every single cup of coffee, that is proportional. That as the cups of coffee increases by 1, the cost at Seattle increases by $2.75. If I add another cup of coffee at Houndstooth, I'm going to also add $2.80. All right, so it says, if you purchase 9 cups of coffee at, at Houndstooth Coffee, how much more would you spend than if you had purchased 9 cups at Seattle Coffee Works? So we are going to just keep multiplying. So if I extended this table and I put 9 here, right, to get from x to y, I have to multiply by that constant of proportionality. So I'm going to say Seattle. We're going to do 9 cups of coffee times that unit price of $2.75. So 9 cups of coffee would cost $24.75. Let's kind of separate the boxes a little bit. Then at Houndstooth, same thing. If I extended my table 9 cups of coffee to get from this column to this column, I'm multiplying by that unit rate. So I'm going to take the 9 cups of coffee times Houndstooth's unit rate, $2.80. Is going to be $25.20. That is not the end of the question. It wants to know how much more would you spend. So I have to find the difference. So I'm going to take the more expensive one, Houndstooth, and subtract the Seattle price. And yeah, I know I typed that wrong. Let's try again. $25.20. I'll move it over here. Minus $24.75 is a 45-cent difference. Oh my goodness. So we would pay 45 cents more to buy 9 cups of coffee at Houndstooth. All right, new table. Says a third coffee shop, Stumptown, is opening in a busy business district. What do you notice about their pricing structure? So what we're going to do is we're going to go find that unit rate. So remember that our cups of coffee is X. The total cost is Y. So for each point, I'm going to do Y divided by X. So 290 divided by 1 is 290. Then we're going to do $5.70 divided by 2 cups of coffee is $2.85. 840 divided by 3 is $2.80. $11 divided by 4 is $2.75. $13.50 divided by 5 is $2.70. And then $15.90 divided by 6 is $2.65 per cup of coffee. So take a second. What do you notice about the prices? Well, I first hope that you notice that they don't have the same unit rate. So they don't have the same price per cup. Okay. But also notice it decreases by 5 cents each cup. So the more cups of coffee you buy, the less it costs. And that would be the benefit. Some places do this, right? The more items of that you purchase, the less it costs. All right, so we are going to practice finding that constant proportionality from each of the tables. I'm just going to do it in my calculator real quick. So I'm going to take y divided by x. So k equals y over x, and we're going to find out what that is. And we're going to see if it's proportional. So 6.8 divided by 2, 17 divided by 5, 27.2 divided by 8, 37.4 divided by 11, and this one is proportional, so its constant proportionality is 3.4. It's proportional because it has the same unit rate. Y divided by x is the same for every single point. All right, this next table, y divided by x, 3 divided by 1, 9 divided by 4, 15 divided by 7, and 21 divided by 10. Each of those was different numbers. So this one is not proportional. Non-proportional. Right, when I did y divided by x, I got a different thing every single time. The last one, we're gonna skip this bit. The main thing to note is that a fraction can also represent the constant of proportionality. It doesn't have to be a whole number every single time. It can be a decimal, a whole number, a fraction, whatever. Okay. So I'm going to take, our x value is feet and our y value is yards. So I'm going to take y divided by x each time. So I'm going to do 1/3 divided by 1 is 1/3. Do a little squiggle to separate it. 2/3 divided by 2 is 1/3. And then 3/3 is the same as 1 whole, so I'm just going to use 1 whole. So 1 divided by 3. I'm going to change that to a fraction, is 1/3. Four thirds divided by 4 is also 1/3. Then 5/3 divided by 5 is 1/3. So our constant of proportionality, k, is 1/3. All right, so we're going to stop there and you can move on.